Okay, in this problem, we need to make the piecewise function f continuous. And as you can see, there's an a value here, so we're going to have to solve for a to make that happen. Now, what's happening in this piecewise function is we have this linear function here that is continuous, because linear functions don't have any discontinuities. This is also a linear function. Okay. And I'm going to use some color here. So I'm going to rewrite this 1/3 x plus 6 in blue. And I'm going to rewrite a minus 2x in red. So we want that blue linear function and the red linear function to meet up on the graph so that there isn't a jump. For f to be continuous, you can't have any jump discontinuities. You can't have any removable or non-removable discontinuities. In order to make that happen, in order to make sure that there's not a jump, and when I say a jump, I'll just draw a quick picture for you. When I say a jump, I'm talking about where one function ends, another one begins somewhere else. So another one begins somewhere else. This right here is considered a jump discontinuity. What we'd like to see happen is we'd like to see that continuity so that where one piece ends, the other begins, meaning that they're going to share the same, that same y value. So their output will be the same when they share the same input. So they're going to share this ordered pair, this xy ordered pair. So let me rewrite this. This blue function, let's just consider this blue function. This blue function, f of x equals 1/3 x plus 6, okay? This is y. This entire expression is y. So when I put a value in, I do the rule and I get an output. But this 1/3 x plus 6 is a y value. It's a y value. This a minus 2x is also a y value. It's an output. So we want the two to equal each other. We want 1/3 x plus 6 to equal a minus 2x. And we want that to happen exactly when x is equal to 9, because that's where one piece of the function ends and the other piece of the function begins. That's where the two have a change in the graph. So if x is 9, I'm going to have 1/3 times 9 plus 6 equals a minus 2 times 9. 1/3 times 9 is 3 plus 6 equals a minus 18. 9 is equal to a minus 18. Add 18 to both sides, and we get a is equal to 27. So the value of a that is going to have these two pieces meet up is 27. Now I'm going to check that. I'm going to have 1/3 x plus 6. Okay, that's one piece when x is less than 9. And then the other piece is going to be 27 minus 2x. X is greater than or equal to 9. And I'm going to put a 9 in to both pieces. So when I put a 9 in to this blue piece, 1/3 times 9 is 3. 1/3 times 9 is 3. Plus 6 is 9. So when I put a 9 in, I get a 9 out. When I put a 9 into this next function, and I'm hoping that this is going to be the same exact ordered pair. This way, where one ends, the other one begins. One's going to have an open circle, one's going to have a closed circle, and that closed circle is going to fill in the open circle, just like I drew up here. When I put that 9 in here, I end up with 27 minus 2 times 9, 27 minus 18, and I get 9. So that was a check right here. This is a check. This checks to make sure that this worked. Now you don't have to do the check. I just did that so that you can be absolutely certain and comfortable of what was happening here and how it works.